Hi, my name is Audrey Clay-Streib, and I'll be doing the Khan Academy video for Chapter 15, Section 2. First, I'm going to go over the problem, some literature about rates of reaction, and the variables we'll be using in this problem. To start, to go over the problem, we are given the balanced equation of 1 mole of chlorine plus 3 moles of fluorine equals 2. You get 2 moles of chlorine monofluoride. From that balanced equation and the given rate of reaction of chlorine, we're asked to find the rate of reaction of fluorine and chlorine monofluoride and the overall rate of the entire reaction. Quickly to go over some literature, we'll be looking at what a rate of reaction is. So defined by that, it is the negative of the change in concentration of a reactant divided by the change in time. So change in reactant over change in time. Something else important we'll also be using in this problem is stoichiometric coefficients. Stoichiometric coefficients are these, the moles of the products and reactants. So we've got, this is 1 mole of chlorine, 3 moles of fluorine makes 2 moles of chlorine monofluoride. So finally, we're to go over variables. Again, we're working with chlorine, fluorine, chlorine monofluoride, and we are given the rate of reaction of chlorine, which is negative 0.012 moles per second, which is the unit we will be using. So to start, we're going to find the rate of reaction for fluorine and chlorine monofluoride. And how we're going to do that is we're going to multiply this given rate of reaction by the stoichiometric coefficient. So to start, we're going to do negative 0.012 moles per second times 3. And from this, we're going to get negative 0.036 moles per second. And this is the rate of reaction for fluorine. So we're going to put that up here, negative 0.036 moles per second. Then to do chlorine monofluoride, we're going to take this again. We're going to go negative 0.012 moles per second times negative 2. And that we're going to get positive 0.024 moles per second. We're going to write that up here. 0.024 moles per second. The reason why we do negative 2 here and not positive 2 is because this is you're forming a product. You're taking the reactants and you're forming a product. So reactants are always negative because you're losing reactant, and products are always positive because you're gaining that product. So that is why we do negative 2 and not positive 2. And to go over why we do 3 and 2, it's because these stoichiometric coefficients again, so 3 moles of fluorine, 2 moles of chlorine monofluoride are created. So that's how we find these. Finally, to find the final rate of reaction, we're going to go down here, go over some equations. We've got the generic rate of reactions. You do this problem, which we've seen in class. To do this, we take the fractions of the stoichiometric coefficients. You see here and here, these are the reactants, and this is the products. Again, you can see products are positive because you're making something. Reactants are negative because you're losing that reactant to then make the product. So what we're going to do is we're going to take what we found above and we're going to plug it into this equation. So we are going to do this. We have negative 0.012, negative 0.036, positive 0.024 all moles per second. And here we see that it's 1/3 and 1/2 for the coefficients. And this is because if you go back to the literature, it says, to quote, the factor of 1/2, in our case it's 1/3 and 1/2, and this definition is related to the stoichiometry of the reaction. In order to have a single rate for the entire reaction, the definition of the rate with respect to each reactant and product must reflect the stoichiometric coefficients of the reaction. So these fractions are needed to have an overall rate for the entire reaction. So what we're going to do, these all cancel. This is all, you don't have to worry about that. This stays negative 0.012 moles per second equals 1/3 times negative 0.36 is also negative 0.012 moles per second. This 1/2 times 0.024 is positive 0.012 moles per second. And this is our overall rate of reaction, and the overall rate of reaction is always positive. Again, you're forming something, so it's positive. So up here, we're going to do positive 0.012 moles per second. And now we filled out the entire table. We've gotten the rates for chlorine, fluorine, chlorine monofluoride, and the rate of the entire reaction. And to summarize again, so we found the rates, and we also use stoichiometric coefficients to find the individual rates and the overall rate of the entire reaction. That's all. Thank you so much.